Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Solving Two-Step Inequalities. Alright, as you can see from the directions, we're going to solve each inequality using inverse operations. Then we're going to graph its solution on a number line. And the reason these are called two-step inequalities is, as you can see, there are two things happening to the variable. Here's our variable, c. It is being multiplied by negative 11, and then being subtracted by 45. But then we're going to reverse that order to do our inverse operations. Even though we use PEMDAS, please excuse my dear Aunt Sally, to figure out what's happening to the variable, we're going to reverse that order, which would actually be SADMEP if you took PEMDAS and wrote it backwards, which means we're going to subtract or add as our first inverse, and later multiply or divide. If that sounds familiar to you, it's because we already learned that back with equations for solving two-step equations. So let's go ahead and do number one together. Inverse of subtracting by 45, adding by 45. 219 plus 45 is 264. If you want to make this add in the opposite, you may to prove that you get a 0. I'm not going to make you do that anymore, but you do need to keep the negative 11 on the c. That does not disappear. From here, inverse of multiplying by negative 11, dividing by negative 11. Make sure that you are keeping the negative here. We do not inverse the sign of the number, we only inverse the operation. Use your calculator. 264 divided by negative 11 is going to give you negative 24. Oh, do you remember the rule that if you ever multiply or divide by a negative on both sides, this inequality symbol must switch direction? Yes, do not forget about that rule. Now, that only happens when you multiply or divide by a negative on both sides. And that's what we did here. We divided by negative 11 on both sides. All right, let's graph this. Negative 24 is definitely going to go in the middle. Since these are negative numbers, negative 23 is on the right, negative 25 is on the left. If they were positives, it would be the other way around. Should I put an open circle or a filled in dot at negative 24? Well, since this inequality symbol has an equal to bar, the way that we show that it can equal the starting number is by filling in the dot, close dot. Which way should I shade? Well, this inequality symbol kind of looks like an L, which means it is less than or equal to the negative 24. So we're going to shade to the left. That's where the numbers will get less. And there you go. Oh, sorry. Let me fix that. There we go. All right, let's do problem number 2 together. And if I went too fast on number 1, you're allowed to hit pause or rewind, do whatever you got to do to make sure you got it all written down properly. Problem number 2, what's happening to our variable? Well, as you can see, the variable is over here, so ignore the negative 328. That is not on the variable. The variable is being multiplied by 25, and then is being added by 72. Once again, we're going to reverse that order. Inverse of adding by 72 is subtracting by 72. If you would like to make subtraction add in the opposite, to be able to do this without a calculator, be my guest. 8 and 2 would make 10. You would carry the 1. 1, 2, and 7 would make 10 again. You'd carry the 1. And then 1 and 3 would make 4. So this is going to give you negative 400. 72 minus 72 is 0. We don't have to write down the 0, but bring down the 25K. All right. Inverse of multiplying by 25 is dividing by 25. We're going to do it on both sides. You might be able to figure out how many quarters would make $4. It's not 4 quarters, but 4 times as much. So this would be negative 16. Should the inequality symbol immediately switch direction like it did back on the last problem? Well, in the last problem, we divided by a negative. Here we're dividing by a positive, so no, the inequality symbol should not immediately switch direction like it did on problem number 1, because we divided by a positive. But something you might remember from the last packet of guided notes that we did, here the variable is not written first. We want the variable to be written first to understand what the answer means. Otherwise, we're going to graph the wrong way with our shading. So, an extra step underneath is required if the variable is not written first on the left. So do this with me. instead of keeping it negative 16 less than k, not that we're going to erase that, but underneath it, we're going to flip it entirely around. So now k is greater than negative 16. That's what this meant. Negative 16 is less than k. K is greater than negative 16. You're like, do I have to do that? Well, if you don't want to shade the wrong way, then yeah, you should always make sure the variable is written first on the left for your final answers of inequalities. Okay, let's put our negatives in the proper negative order. Forgive me for being repetitive, but if these were positives, then 15 would be on the left, 17 would be on the right, but negatives go reverse order from positives. This time, my inequality symbol does not have the equal to bar. Here it did on number 1, so I filled in the dot. But here it does not have the equal to bar. So here I'm going to keep this an open circle. Which way will I shade? Well, k is greater than the number. Greater numbers are always to the right. Yes, it kind of matches the inequality symbol, but you shouldn't even have to use that trick. You should know greater numbers are to the right. Okay, we have now done numbers 1 and 2 together. I would like for you to try number 3, which is on the right side of your page. Also number 4, which is on the next row over on the left side of your page. And then there's also a 5 and a 6. I would like for you to try all 4 of those problems on your own and then hit play when you're ready to see how you did. Okay, have you already done 3, 4, 5, and 6? If not, you better hit pause now and do them. Here we go. Number 3, the variable was divided by 8, subtracted by 6. So you should reverse that order. And the inverse of subtracting by 6 is adding by 6. You do it on both sides. Bring down the n over 8. The negative 6 and the positive 6 gives you 0. You don't have to bring anything down there. Negative 22 and 6 is going to give you negative 16. We're not done. Inverse of dividing by 8 is multiplying by 8. Negative 16 times 8 is negative 128. Since you're multiplying by a positive, the inequality symbol does not switch direction immediately. However, since the variable is not on the left, it's over here on the right, we're going to have to rewrite the entire answer underneath as an extra step. And now say that n, no longer less than or equal to, everything flips around now, greater than or equal to negative 128. If you did not do that, then you're probably going to graph the wrong way. Do you have your negatives in the correct order? Negative 129 is on the left, negative 127 is on the right. Did you have a filled in closed dot? Because this had an equal to bar. So you fill in the dot. Since it's greater than, this inequality symbol does not look like an L, so it's not less than, it's greater than or equal to. The greater numbers are on the right. Problem number 4. Inverse of adding by 55. Did I say 55? I meant to say 58. Inverse of adding by 58 is subtracting by 58. Negative 6y gets brought down. 12 minus 58 is negative 46, not positive 46. Whenever you have a smaller positive minus a bigger positive, it's going to put you in the negatives. Inverse of multiplying by negative 6 is dividing by negative 6. And since you're dividing by a negative, the inequality symbol should have switched or reversed direction. Did you reverse the direction of the inequality symbol? Immediately. This is not like problem number 3 where it was an extra step. It was an extra step on number 3 because the variable was on the right, so we rewrite the entire answer with the variable on the left. Number 4 is a different story. Variable was already on the left, but since you divided by a negative, the inequality symbol switches direction immediately. Okay, there were only 2 hash marks on your number line because this is a decimal answer. Now you could also write it as 7 2/3. It is in between 7 and 8. But it's not closer to 7. If it was 1/3 or 0.3 repeating, then it would be closer to 7. But this is 0.6 repeating, which is 2/3. That is closer to the 8. Past the halfway point, closer to the 8. Oh, this graph is wrong. Oh my goodness, I need to fix this. Ladies and gentlemen, this is wrong. This is less than. You should be shading to the left. I apologize for not proofreading my answers. My goodness, that was a mistake. So do not shade to the right. It's less than, you're going to shade to the left. Forgive me for that mistake. Okay, problem number 5. This one's a little bit trickier. The inverse of adding by negative 37 is subtracting by negative. You probably already made it adding a positive. If you want to make it adding a positive right away, because you realize a negative 37 plus a positive 37 would give you the 0, not that we show the 0 step anymore, then that's totally fine with me. You don't have to make it minus a negative first. But you do have to realize that it has to become adding a positive to make this 0. That's going to leave you with x over 12. Negative 29 plus 37 is going to give you 8. If you already messed up, hit pause and fix it. And then hit play when you're ready to move on. The inverse of dividing by 12 is multiplying by 12. That's going to give you 96. The inequality symbol does not switch direction when you multiply by a positive. Did you keep your numbers in the positive order, where 95 is on the left, 97 is on the right? You should have an open circle shaded to the left because it's less than. So you're shading left, and it doesn't have an equal to bar, so you're leaving it an open circle. Problem number 6. This was the trickiest problem to solve because the variable was to the right of subtraction. You cannot read backwards to answer what's happening to the variable. If you told yourself the variable was multiplied by 32 and then it's subtracted by 51, and therefore you would add by 51, no. You cannot read right to left with subtraction. You can't. So, as I taught you back in the equations teachings, if the variable's to the right of the minus, you have to make it adding the opposite first in order to read right to left. Your first inverse should have been subtracting by 51, not adding by 51. Ladies and gentlemen, if you added by 51, stop and ask yourself, would 51 plus another 51 give you 0? No way. But 51 minus 51, that would give you 0. So, if you messed this starting steps up, hit pause now. Learn from your mistakes. We all make mistakes. It's not the end of the world as long as you learn from your mistakes and fix them right now. So hit pause if you need to fix this, and then fix everything underneath, because that's going to change what you do from here, because now we have a negative 32W, not a positive. Feel free to hit pause and fix what you got to fix. Okay, moving on. Inverse of multiplying by negative 32 is dividing by negative 32. And this will now switch the direction of the inequality symbol because you are dividing by a negative. So the inequality symbol has to immediately switch direction. If you did not get 0.75, if you got 1.3 repeating, then you entered the division problem in backwards. Negative 24 was on top. That should have been entered into your calculator first. Then divided by negative 32. If you do it the opposite order, you will not get 0.75. You will get 1.3 repeating, which is wrong. Okay. This number line was pre-made for you. Do you know where 0.75 is located? It's here. Why? Because if you count by quarters, 0.25, 0.5, 0.75, that's where the dot should go for the 0.75. Since it is equal to bar, we fill in the dot. Since it's greater than or equal to, we're shading to the right. Okay, one more thing to go on these guided notes, the bottom section. Did you know that you can actually check your solution for inequalities? For example, on number 2 above, which we already solved, by the way, you can replace the k in the original problem, in the original inequality, with any number that satisfies the solution. Now, this part is key. You might want to underline this. You have to replace k with something that satisfies the solution. This is not as easy as it was with equations, because this is not an equal to sign. This was greater than. And by the way, k greater than negative 16, I'm not pulling that out of thin air. If you go back to the top of your page and look at how we solved number 2, that's what we got. K greater than negative 16. So I'm not pulling this out of thin air. So what satisfies that solution? What satisfies the fact that k must be greater than negative 16? Well, you have to pick any number that is greater than negative 16. Now, think about this in terms of the number line, and you can look back at number 2's graph to help you understand what's going to satisfy it. The numbers greater than negative 16 are to the right of negative 16. So negative 15 would be a great choice. So let's put that in. Are you ready? Pencils in your hand. Let's pick negative 15 because negative 15 is greater than negative 16. If you looked at the graph, you saw what I meant. So replace it. Now we have this. And we are going to enter this into our calculator. Do it right now. 25 times negative 15 plus 72. And if you do that correctly, you should get negative 303, which you should go ahead and write that down with your pencil. And now I want you to ask yourself, is the inequality that you end up with, is it true? Is negative 328 less than negative 303? The answer is yes. Now, how do I know it's yes? Because less than means to the left. Is negative 328 on a number line to the left of negative 303? Yes, it is. So since this is true, in fact, I'm going to go ahead and put a check mark here. This is true. It proves that the answer we got from solving problem number 2 at the top of the page, it proves that it is correct. All right, that concludes our guided notes on solving two-step inequalities. Thank you for watching. We'll see you next time.